Hello guys, nice to meet you again. Okay, today I will talk about the Sweetcomb. It's a unified management agent. Actually, first of all, I need to thank all the guys from different companies, and they provide great support for this project. When the project was founded, I think 6 months ago, we have 12 companies from global, such as Cisco, China Mobile, China Telecom, Tencent, Alibaba, and also Huawei and ZTE. They help us to create this project. When we developing this project, any guys from the Cisco, Advanic, Ray Kinsler from Intel, and also from Penson Technologies, Andrew, Real Estate, and all the guys, and from T2 and Tencent, they also contributed lots of code to this project. Okay, this is today's agenda. First, we will talk about why we create this project, and then we will talk about our architecture and the roadmap, and then we will explain the software implementation, and also the telemetry in cloud, and then we will talk about current status, and we will next steps. And we have published 2 release, and we will talk about the details on the release, and then the summary for this project. Okay, first of all, why we need to create this project? You know, on the left side, this is a traditional development for products for VPP. Actually, from the top to the bottom, on the top side, we have orchestration layer and SDN controller. They will configure the uCPE through the Netconf, RESTconf interface, or gRPC interface. So all the configuration will go to the management agent. Here we run the Sweetcomb, and then we will do some translation, and then configure the VPP data plane through the low-level APIs. So why we need to create this subject? When we apply this on the edge access the devices or edge cloud, we found that there are problems here. One is for edge, we have limited resources, such as limited CPU cores and limited size of memory. And for edge, because you know edge, there are lots of subscribers who access the network. They have different configurations, and this configuration are changed frequently. So that's why we create this project to fix all the problems. Okay, this is the roadmap for Sweetcomb. It's very complex, so I will explain it from the top to the bottom. On the top layer, it's the orchestration layer and the SDN controller layer. We will plan to support all the merge, control, and orchestration. So such as ONAP. Actually, for the first use case on ONAP, the residential CPE is developed on VPP, so you can use it on VPP. And Kubernetes, we also provide support to integrate with Kubernetes. And of course, for SDN controller, open source, the OpenDelight and the ONS, we also can integrate it with the Sweetcomb and VPP through the Netconf and the RESTconf interface. And we also provide some statistics to the upper data collector. Okay, on the second layer, it's actually is a Ranko. It's the Sweetcomb scope. It contains 4 parts. One is the transport layer. The second is Yang model layer, and then the data store, and finally the translation layer. So on the transport layer, we will plan to support 4 interfaces: the Netconf protocol, RESTconf protocol, and also the gNMI protocol. gNMI is the gRPC-based protocol. And we also plan to support the SSL. On the Yang models, currently we will support the two main Yang models. One is the IETF, and another is OpenConfig. IETF is mainly maintained by the IETF interface organizations, which is used for the telecom equipment. And OpenConfig is organized by the OpenConfig, so it will be used for the cloud. On the second layer, it's the data store layer. Currently, we are leveraging the sysreport data store. It can be used on the configuration and operation state. The key part is the translation layer, because we will support different data planes. Such currently we support the VPP, DBTK, and the Kono data plane. So for the translation layer, we need to translate different Yang models to different data plane APIs. Such as for APP, we will some different translation layer. For translation the IETF Yang models to the VPP APIs. Also, we need to provide the OpenConfig Yang models to the VPP Yang models APIs. Also, for DBTK, we also the similar plugins. On the operation system, currently we will support the different packages as the VPPs, such as the DB packages, RPM packages. And for hardware, we also need support the CPU, memory, and NIC operation. We also support the Intel Quick Assist technology and the FPGA and the Wi-Fi. Okay, this is the software architecture for Sweetcomb. Currently, they have three key components. We will explain it from the left to the right side. On the left side, of course, we support three interfaces. One is the gNMI. There are two parts for gNMI. There are client and the server. They are communicated to each other through the gRPC protocol and also the Google protocol buffer protocol. For the Netconf, we have also the client and the server. They are communicating with each other through the SH and the XML or JSON format. And currently, we support the gRPC and the Netconf protocol in our release. But in next release, which means the 1908 release, we will support the RESTconf protocol. On the middle side, we have three data stores for the high availability, which means the candidate data store, run data store, and the startup data store. Okay, the sysreport engine is the engine of the sysreport project, which can be used to configure and operate the three stores. On the right side, there are the translation layer and the sysreport plugin. So all the Yang models and the features, we can act as the plugins, so you can enable it or disable it. So for the whole picture, there are 5 steps when you start the Sweetcomb. The first one is when you run the sysreport plugin D, then it will open a sysreport plugin firewall. When it's done, the Sweetcomb project will download the initial configuration from the startup data store to the running data store. And then the sysreport plugin will subscribe to the sysreport engine for specified events. Then when the SDN controller or orchestration config or need to get some information from the VPP, all the information will go to the candidate data store or running data store. When the running data store detects a configuration change, it will notify the sysreport plugin, and the sysreport plugin will configure the VPP side through the APIs. Okay. This is one of the combination for the Sweetcomb, which means we will command the IETF Yang models and the Netconf interface. On the left side, the Netconf client will communicate with the NetOP2, which is the Netconf server, through the Netconf protocol and also SH or TLS. Then the Netconf server will configure its configuration to the syslabore engine. And then the syslabore engine will put this information in the data files and the Yang models data store. Also, for the local application, you also can configure your information through the Google protocol buffer protocol to the syslabore engine. People may have a question on this. Why we need to support the OpenConfig? Because OpenConfig is organizations which purpose is to build Yang models for cloud vendors. It's created by different service providers such as Google, Apple, Amazon, Facebook, lots of top service providers, because they think the IETF defines the Yang models is very slowly, so they propose their project and define lots of Yang models in a short time. So we can see currently they have defined different Yang models for the routing, MPLS, and policy, and also support the different interfaces and the layer 2, and also they also support the different for telemetry and OpenFlow. They also define the Yang models for Wi-Fi and the optical transport networking. So this is another combination for the OpenConfig Yang models and the gNMI interface. Actually, it has a similar process as IETF Yang models and the gRPC. So from the left to the right side, we will explain that on the left side, it's the gNMI client. It will communicate to the gNMI server through the gNMI interface protocol. So for the gNMI interface, the server, it will configure its information to the syslabore engine through the GPP protocol. And also, the syslabore engine will configure its information to the data files and the Yang models. When the syslabore engine detects the configuration change, it will notify the syslabore client library. Here, on the OpenConfig to VPP plugin, it will configure the change to VPP through the VAPI. So for this, we needed to support different interfaces, but the difficult part is that for different Yang models and different interfaces, even though they have the similar operations such as the config, get, edit, but they have different detailed operations to the data store. So we can see from the because we currently support two interfaces, the gNMI and the Netconf, we will explain it in details. So we can see the green anchor is the RPC argument. For the gNMI get, it will three different parameters. One is the OR, which means we need to get the configuration or state. And another is the configuration or state operational. So for the configuration, we will get the configuration from the data store in the syslabore engine. But for the state, we will get the information directly from the syslabore plugin and the VPP part. So Okay. VPP side has provided a framework for the statics. So in the gNMI server, we also provide a framework to get the statistics from the VPP data plane for the cloud native applications. We will explain it from the top to the bottom. When their packages are running in the VPP site, the VPP graph node will get all the statics, and this information will put into the shell memory in the VPP site, and the VPP API will read all the statistics from the shell memory and put it to the gRPC server. In the gRPC server, we have a thread to collect all the information and also put all the statics through the gNMI to the data collect. In the data collect, it will also push all the statistics to the GUI interface, such as the CNCF project, Prometheus project. It helps us to provide visibility to the data plane features. Okay, this is the current key progress. Actually, Sweetcomb project was founded on November last year. Initially, it had 12 founders and also 15 committers from these companies. Actually, currently there are 12 bigger partners buying as founders, 2 from the USA, 2 companies from Europe, and 8 companies from China. I classify these companies simplified. Maybe it's not correct, but I just say it's a full ecosystem. For the silicon vendors, we have Intel and NXP. And for the networking vendors, we have ZTE, Cisco, and Huawei. On the telecom operators, we have China Mobile, China Telecom, and China Unicom. And for cloud service providers, we have Tencent and Alibaba. For the ODM vendors, we have the Huasentel. And for the IT service vendors, the Tito is from Europe. Okay. Actually, also we have published 2 releases since its founding. The first release is published on the February this year, and the second release is published on April this year. Although we have just created this project for 6 months, but there are many customers are using it now, and some customers are put this Sweetcomb into their deployment in production. Okay, we'll explain some release notes for what we have done for the release. For the 1901 release, we support the Netconf and the gNMI in the northbound interface for the SDN controller and the orchestrator. And for IETF Yang Models, we support the interface. For OpenConfig Yang Models, we support the interface and the local routing. And the data store, we integrate the Sysbro configuration and operation data store into it. And also, we have translation layers such as the IETF interface and OpenConfig interface and the local routing. We also provide a connection to the VPP and reconnect. For that last release, the 1904 release note, we also provide more features. One is the initialized gNMI server, and we also added the support for the IETF net Yang models and the translation and the test use case. And for high availability, we also support the VPP health check. Besides, we also did the reflect to all the code, such as clean up, rebuild the build system, and rework the interface and local routing. The big part is the test framework. We added the unit test framework into this project and add some unit test case for the interface and the locality. Also, we also built a Docker environment to help us to integrate the Sweetcomb and VPP. Okay, this is the release plan for next release, which means the 1908 release. First of all, we will integrate the gNMI with sys report data store, and we will support the SEL, Yang models, and translation and the test case. And also, we will support the DNS MassQ, Yang models, translation and test case. Also, we will support the REST-conf protocol implementation. And for high ability, we will replace the connection and use the VPP VM because it has more rich features than we originally Sweetcomb plugin. And based on the VM, we will implement the VPP restart mechanism and also the Sweetcomb restart mechanism. And finally, we will do some integration for the configuration telemetry and the SWAT integration. And we also do some refactor to the framework to help us to do the flexible and the modular plugin registration and unregistration. Okay, this is the summary for this. Actually, we utilize the leverages the Sweetcomb to help us to accelerate the control plane with low CPU costs and low memory, and we plan to get high performance for this. And we will provide the Netconf and the REST-conf interface and the IETF Yang models for the telecom use case, and provides the gNMI interface and OpenConfig Yang models for cloud. Okay. So finally, welcome guys to join this community and give us some requirements, your lessons from this project and your proposals for this project. Thank you.